Hello chemists, today we are talking about ionic compounds, and let's dive right in. Our big idea for this lesson is that ionic compounds combine metals and nonmetals in a ratio such that there is no charge. An ionic compound is a compound that forms when a nonmetal steals electrons from a metal. This results in a neutral compound, or a compound that has no charge, where all of the atoms have either completely full or completely empty valence shells. We'll see that the nonmetals have full valence shells, and the metals have empty valence shells, because the nonmetals have taken the electrons out of the metals' valence shells. When we think about how ionic compounds form, one strategy that we use is the rule of zero charge. This rule states the formula of an ionic compound is correct when the charges of the anions and the cations sum to zero. This feels like a lot, but let's break it down with a few examples. Our first example is a compound that forms between magnesium and chlorine. Step one is to find the charges of those two atoms. Using my periodic table, I know that magnesium will form an ion with a +2 charge, and chlorine will form an ion with a -1 charge. Now I want to think about how many magnesium atoms and how many chlorine atoms I'll need to get my overall compound to have a charge of 0. I like to use this formula. The first numbers in each set show the quantities of my two atoms, and then the numbers in parentheses show my charges. So in this case, I'm trying to figure out those first numbers. If I have one thing with a +2 charge and two things with a -1 charge, that gets this formula to be 0. So 1 magnesium and 2 chlorines. This gives me a ratio for my compound of 1 to 2, 1 metal to 2 nonmetals. And I would write my formula as MgCl2. That subscript, the little 2, tells me the quantity of the element that comes right before it, so 2 chlorines. Another example is a compound that forms between Na and O. Looking at my periodic table, I know that sodium forms an ion with a +1 charge, and oxygen forms an ion with a -2 charge. I need two things with a +1 charge to balance the -2 charge on oxygen. So 2 + 1 plus 1 - 2 gives me 0. My ratio is 2 metals to 1 nonmetal, and I would write my formula Na2O to show that there are 2 sodiums and 1 oxygen in this element. These two examples are typical in that they have the same kind of metal and the same kind of nonmetal, right? There's only 2 kinds of elements in each compound. I wouldn't have a compound, for example, that's Na +1, Li +1, O -2, even though that sums to 0 charge. We don't see that ionic compounds form that way. For now, you can think about them as just being one kind of metal and one kind of nonmetal. Another way to think about this is that atoms form ionic compounds when the total number of valence electrons is 8 or some multiple of 8, like 16, 24, 32, or so on. Let's look back at these two examples again. So magnesium has 2 valence electrons, and each of our 2 chlorines have 7. That gives us a total of 16 valence electrons. So here we have the electrons in their initial positions. These atoms are all neutral. They have the same number of protons and electrons. And these images are just showing the valence shell. So chlorine is going to take the electrons. They're going to move from magnesium's valence shell onto the 2 chlorine valence shells. And then it'll look like this. So magnesium, our metal, has an empty valence shell, and the 2 chlorines have full valence shells. You'll see the charges are written in there. The -1 reflects the gain of the electron, and the +2 reflects the loss of 2 electrons. Let's look at our other example. The two sodiums in Na2O each have 1 valence electron, and oxygen has 6 valence electrons. When we add those up, we get 8. Here are our initial neutral atoms. Oxygen will take those 2 electrons from the 2 sodiums, and we'll end up with our metals having no valence electrons and a +1 charge, and our nonmetal having a full valence shell, 8 valence electrons, and a -2 charge. So you can think about this in whatever way works best for you. If thinking about the charges and the ratio works best, that's great. If thinking about the total number of electrons works well, that's great too. The last idea in this lesson is how we name ionic compounds. We always write the metal first and then the nonmetal. That matches the periodic table with metals on the left and nonmetals on the right. And we always change the ending of the nonmetal to IDE, which we pronounce "ide." So, for example, a compound with magnesium and chlorine becomes magnesium chloride, and a compound with sodium and oxygen becomes sodium oxide. You'll notice that there's no indication of how many of these atoms there are in the names, and that's because we can figure it out pretty easily from the charge, like we did on the previous slides. I've listed out all the common anions here, and I'm going to say them so you can hear the pronunciation, but you can come back to this if you're having trouble with some of the trickier ones. So anions with a -1 charge include fluoride, chloride, bromide, and iodide. Anions with a -2 charge include oxide, sulfide, and selenide. And anions with a -3 charge include nitride, phosphide, and arsenide. That's it for today. If you have any questions, you can leave them in the comments below.